Hello, my wonderful students. I hope you're enjoying yourself. I hope you're enjoying our class, our visual class. You're welcome to your basic science class. And we'll continue from where we stopped on formation of chemical compounds. From the last one we did, I noticed that some of you actually understood the topic, and while some still need some touches. And I know I've given you some corrections. Okay, so today we will be taking the formation of chemical compounds in another dimension. Writing these chemical formulas with compounds that contain polyatomic ions. That's formula of chemical compounds containing polyatomic ions. Now first, I want you to know the meaning of polyatomic ion. What is polyatomic ion? I hope you know that ions, you can actually call them radicals. Okay. Now, a polyatomic ion has two or more different atoms of elements bound together, which behave as a single unit. When you look at them, they are two. You can see two atoms together, and they behave as one. And because they behave as one, they have same valence. You have something like hydroxide. Hydroxide is a polyatomic ion. Now, this hydroxide has one as its valence. It acts as one. You will not say that hydrogen is different, oxygen is different. No, they are the same. Hydroxide, they are the same. They behave as one. Okay, let me give you some examples of this polyatomic ion. And when you look at this table, this P.ion represents polyatomic ion. Then their full names, their charges, and their valence. Number one, you have ammonium ion, NH4. Ammonium ion, you can see that plus there. That plus means that it's positively charged. And remember, I told you, if the charge, if the state of the ion is 1, you will not write it. But if it is 2, you will write 2. Let's assume that this ammonium ion is plus 2, you see, I will write that 2 there. But because it is 1, that's why you are just seeing only plus. So the charge is plus 1. Then the valence is 1. Remember, the valence is that number close to that charge. Okay? The next one is trioxocarbonate 4 ion. You may say, Auntie, why are you calling it trioxo? Now, when you look at that CO3, now let me ask you a question. CO2, if I say, tell me the full name of CO2, what will you say? You may say carbon dioxide. Okay, meaning that 2 there is di. So this one now that has 3 here is tri. If it is 1, it will be mono. If it is 4, it will be tetra. So trioxo is showing you that the oxygen is how many? 3. So trioxocarbonate 4 ion. You have 2 minus as its charge. The valence is 2. Hydroxide ion. Hydroxide ion. Tetraoxosulfate 6 ion. You can see what I told you now. Because of that 4. Remember I said if the atomicity of that polyatomic is 4, it will be what? Tetra. If it is 3, it will be what? Tri. If it is 2, it will be what? Di. Okay. So here we have tetraoxosulfate 6 ion. Then trioxosulfate 4 ion. Trioxophosphate 4 ion. And then the last one is trioxonitrate 5 ion. Now, how do we use them to form a chemical compound? While using this polyatomic ion, you should note this. that this polyatomic ion should be placed in a bracket. Why do we need to place it in a bracket? You will see it now. From this example, you have aluminium tetraoxosulfate 6. Now, how do we write them? You have the solution there, aluminium tetraoxosulfate 6. What is the symbol for aluminium? Yes? AU, no, that's wrong. AL, that's correct. AL. Then tetraoxosulfate 6, SO3, no, that's wrong. Remember what I told you. If it is tetra, that means the oxygen is how many? 4. That's wonderful. So it will be SO4. Now you can see that this S4 will be SO4 will be put in a bracket. You put the polyatomic ion in a bracket. Okay, now you write their valence. Aluminium, the valence for aluminium is what? 3. And tetraoxosulfate 6, 2. Good. Now you draw your arrow from aluminium pointing to the valence of tetraoxosulfate 6, which is 2. What will you have? Al2. That's correct. Al2. Then the next one will point from that tetraoxosulfate 6 to 3. Then what will you have there? SO4 bracket 3. SO4 bracket 3. Now, let's assume you didn't put this bracket. What do you think it will look like? It will be SO43. That's SO43. So that's why it's advisable you put this polyatomic ion in a bracket. Is that okay? Okay, let's move forward. Second example, sodium trioxonitrate 5. Now, what's the symbol for sodium? SO is strong. Remember, sodium has a Latin name. What's the Latin name? Natrium. Correct. Now, the symbol is gotten from that Latin name, Na. The symbol for sodium is what? Na. Then the symbol for trioxonitrate 5 is what? NO3. And what do we do now? We'll put the polyatomic ion in a bracket. Then we'll write their valence. The valence for sodium is what? 1. Then trioxonitrate 5 is also 1. Then you draw your arrow from sodium to the valence of trioxonitrate 5. And you have Na1. Because it is 1, we will not write it. We'll just write Na. Then we'll also draw the arrow from NO3 to 1. What do we have there? NO3 bracket 1. But because it is 1, we'll still not write it. Is that okay? Okay. Now, since their valence are 1, you can actually remove the bracket. There's no number there. When you look closely, you can see there are no numbers written there. Let's assume you have 2, NO3 bracket 2. You will not remove the bracket. But because it's NO3 bracket 1, you can actually remove the bracket because the 1 is not written. Is that okay? Okay. The next one, aluminium hydroxide. Aluminium is Al, and hydroxide is what? OH. The valence of aluminium, 3. Wonderful. And that of hydroxide, 1. That's good. That's good. That shows you are paying attention. Now we'll draw the arrow from aluminium to the valence of hydroxide, and that will give us what? Al1. Do we need to write the 1? No, that's good. Then from OH, we'll draw to the valence of aluminium, which is 3. You have OH3. If you don't put this OH in brackets, what do you think you'll be having there? You have AlOH3. You can now see that that 3 will look as if it's just for H. But if you put it in the brackets, once you look at it, you will know that the 3 is for both O and H, because these OH, they are behaving as 1. Is that okay? So don't forget, whenever you are writing any chemical compound involving these polyatomic ions, to put them in a bracket. Is that okay? Okay, so do this. Number 1, write the chemical formula of the following. Calcium trioxocarbonate 4. 2. Ammonium sulfide. 3. Magnesium trioxonitrate 5. 4. Aluminium tetraoxosulfate 6. And 5. Ammonium tetraoxosulfate 6. God bless you. Stay safe. I miss you all. Take care of yourself. Bye for now.